Let's get started. Good evening, everybody, and welcome to Modern Day Debate. We hope you're doing well this evening. We welcome you to another juicy exchange of flat versus globe. And get us started tonight. We have ADHD projects. The floor is all yours, and thank you so much for being here.
Okay, perfect. Can I go ahead and share? Oh,
Yeah. You should be good to share through the
sorry.
Zoom.
I had the live open on another tab, and so you got done talking, and then you started talking again.
Oh, yeah, you might want to mute the audio on the other end.
Yes, it is gone. I got it.
There you go. No worries. So we'll give you 10 minutes on the floor, and as soon as you're ready and you get your screen share up, I'll start the timer.
Okay, let's see if I can slideshow share.
This is a good opportunity
Okay,
for everybody to hit that like button. Oh, and I start at the worst time. There we go. Floor is all yours. 10 minutes.
okay. Can you see my screen?
We can.
Okay, perfect. So this is obviously a flat versus globe Earth debate. This is not a globe disprove globe debate. This is a flat versus globe debate. So first thing is, who has the burden of proof? So this kind of debate is called a formal debate. It's not like a trial or anything like that. Formal debate. Um, so in formal debates, the game, quote unquote, in which two sides are given a topic and follow a set of rules to see which side wins. Each team has the burden. And then that comes from futurelearn.com. So neither side, neither globe Earth or flat Earth, has the full burden or is free of burden. They both have equal burden of proof. So here are the topics that I'm going to go over that prove that the Earth is a globe. So first thing is star trails in the southern hemisphere. Now, on the typical flat Earth, I know you guys don't say model, but on the typical flat Earth model, you have a flat disk. We don't know what's on the other side of it. It's not floating in space, but there is a dome over it, typically with stars that rotate around the center point. Now, star rotations in the north is expected in this model. They go around a singular point. There is the North Star that is about at that point, and it all makes circles around that. However, in the southern hemisphere, this same phenomenon happens. This picture here is a time lapse taken from somewhere near the equator, somewhere that you can kind of see a little bit of both of them. You can't quite see the axis on one of the sides, but in this photo, this is taken from australianphotography.com, showing the southern star trails. This is an impossibility on the flat Earth. The going around a singular point on a flat Earth doesn't work. On a globe Earth, it is expected. This is a phenomenon that you see anywhere in the southern hemisphere, that you can see the southern central point. Okay. And then the second is sunsets in general disprove the flat Earth. I have a video here. We're not going to watch the whole thing, but there is, let's mute it, a video of the sun setting. Let's go ahead and turn that playback speed up. So this is a video of the sun setting, and oops. You can see it does set bottom up, and then goes until it is completely gone. And then we actually get a different view of the same exact sunset. These are both filmed by a P900 at the same time. And it is a zoomed in version. So when flat earthers say that, well, if you zoomed in on it, the sun would come back, that is just categorically false. Here it is zoomed in and the sun is not coming back. In fact, you can see it is obstructed by the horizon. And then just for the record, here is their double camera setup. And then sunsets by hemisphere also prove the Earth is a globe. In the northern hemisphere, the sun as it sets will move to the left. In the southern hemisphere, as the sun sets, the sun will move to the, in the north, it moves to the right. In the south, it moves to the left. And then at the equator, it will go straight backwards. This is something that cannot happen on a flat Earth. As the sun goes around the flat Earth, we should see it cut to the right always. So we should never see it cutting to the left. This is because on a globe, you have the hemispheres, and as you are rotating away, the sun is rotating in the middle, and you get that cutting because you're at an angle to each other. And then we've got horizon dip angles. Now, no matter where you're at, the horizon is always slightly below your eye line. Normally, when we're on the ground, we can't really see this. It's about where our eye line is if we can actually see the horizon. But as we go higher and higher, the horizon starts to drop from view. And the higher you go, the more this dip is. This is the horizon dip angle. On a flat Earth, the horizon should always rise to eye level. This is incorrect. Or I'm sorry, this is what we do not observe this on in reality. So yes, these are both. So the one on the left here, I believe, is a theodolite. The one on the right is from an airplane. And then this one is one that anyone, sorry about the quality. I downloaded this while I was at a high school. So the internet blocked the actual site it was from. So I got the thumbnail. But this is a version of the same thing. This is a water theodolite because we know, as flat earthers say, water always finds its level, that when we line these two tubes up, that the water is level to your eye and you look down and they're straight across. So at sea level, this line is level with the horizon. As you go up, this line gets lower and lower as you gain elevation. So at 360 meters or 12,000 for you Americans, and then 17,000 or 1,700 meters or 5,600 feet. We see that drop in horizon. So these are proofs that the Earth is a globe. Another proof is boats going over the horizon. This is something that no flat earther has ever been able to do, is take a picture or a video of a boat that has disappeared over the horizon and zoom it back in. They'll always show you something that is gone and then they'll zoom it in from there, but they will never show you a boat partially obscured and then zoom back in. This alone shows that the Earth is curved, or at least the water in between us and the boat is curved. And then the last one, the angles of elevation across three observers. This is more commonly known as the Eratosthenes experiment. Eratosthenes, it doesn't matter if he existed or not, the experiment, it still stands. Because the sun is so far away, the sun's rays are coming in basically parallel. We observe this every day. All shadows coming from the sun are parallel. And so we can measure the angles from that those shadows make to the sun, and we're able to use the properties of a triangle to get the elevation of the sun, or at least what we would expect on the flat Earth. And when we do this, I'll just read, there's an experiment done by millersville.edu. It says, using the values 50 degrees and 60 degrees and measured on the trip with b equals 1,000 miles, we find that h is approximately 2,000 miles. This relatively close sun would have been quite plausible to the ancients. So plausibly, the sun could have been close. However, continuing the calculation, we find that A is approximately 2,400 miles, and two distance R1 and R2 are approximately 3,000 and 3,900 miles, respectively. So that's these two distance here. That is, as we move from Florida to Pennsylvania, our distance from the sun increases by about 30%. As a consequence, the apparent size of the sun should decrease by 30%. We see no noticeable change in the apparent size of the sun as we make the trip. We conclude that the flat Earth / near sun model does not work. So these are an experiment that shows that this one specifically shows that the sun should have changed angular size as you moved away from it. However, they found that it did not. And that is the end of my presentation. So I'm going to go ahead and stop sharing and yield my time.
Awesome. All right. Well, thank you so much for your introductory statement there. So we are going to hand the floor over to FlatterDay Saint, but I'm just going to do a quick little bit of housekeeping. So let me just grab my broom right quick. I want to let you know that at Modern Day Debate, we are a neutral debate platform hosting debates on science, politics, religion. We do hope you feel welcome and that you subscribe and like to our stream because it helps us out big time in the algorithm. And I do want to just quickly mention, if you aren't subscribed, you are going to miss out on these live on YouTube. So definitely hit that subscription if you're watching on podcasts so that you don't miss out on these live events. So you can ask questions to the speakers. And I'm going to hang up my broom and we're going to hand it over there to FlatterDay Saint. So thank you so much, FlatterDay, for stepping in and doing this debate. We really appreciate you being here. You have 10 minutes on the floor. Oh, you're on mute. Sorry, I put you on mute there because there's a little bit of background noise because we did set up a different audio input for FlatterDay. So you just want to take yourself off mute there, FlatterDay, on Zoom. Sorry about that. There you are.
All right, it's cool.
I can hear you now. Sorry about that.
So he started off by saying that the globe doesn't have the burden of proof, but as far as anybody can see or to their own eyes and their senses, the Earth appears to be flat and stationary. So it's an extraordinary claim that it's a sphere and it's spinning when we don't witness that. So therefore, the burden of proof doesn't land on me because I'm not making any claims. I'm just debunking his claim about the Earth being a globe, because the Earth isn't completely flat all the way through. It has valleys and hills, so it's different terrain, but all the way across the board is generally a flat plane. And so the southern and northern star trails, it's just like if you looked at a light from one side of the room and then you went to the other side of the room, you're going to see a different side of the light. As far as the circular pattern, I think the circular pattern proves flat Earth more than anything. People that are into like astrology and the zodiac, they still use the zodiac wheel, which if you do your research, you'll see that they're still using the flat Earth model because it works. That's what they say, and there's no need to change it. So the way that they get the way that people get a horoscope, like for their sign, is they take a map of the star trail for that night and they match it up with the map of the sun trail for that day, and they put it over, and wherever the sun happens to be, like let's say the sky was like a record, right? And every time it spins, it goes a little bit further out or a little bit further in. So it appears that the sun does this, and that's how they get the zodiac signs, which I'm not saying are true or not, but I'm just saying there's a lot of people, even heliocentrics, that are still using the flat Earth map for the sky charts at night, which is still based on a flat Earth. So they haven't changed it to globe. Okay, so if we were on a globe, we would see different star patterns every single night. It would be like gluing a GoPro to a basketball, spinning the basketball on your finger, then getting on a roller coaster ride and expecting to see the same people at the same hot dog vendor or the same kids walking through or whatever. You're going to see something completely different. From every second to the next, you're going to see something completely different. There's no parallax. As far as sunsets, disproving the flat Earth, I don't think it proves either globe Earth or flat Earth, except for the fact that it sets on the horizon, which means horizontal. The sunset, who's to say that the sun doesn't dip underneath the flat Earth, and therefore you're seeing the sunset on the flat Earth? There could be so many different things that we could speculate on, just as the heliocentric model speculates on things they don't even know. How could the sun even be just a burning ball of gas without continued fuel to it? Nothing can just burn continually without fuel. It doesn't make any sense. You can't prove it on a smaller scale, so it doesn't work. It's just basically a theory. As far as the sun moving left at the north, I believe you said, I don't know about that. I've never been there, so I can't say. And I don't believe any videos that are, things that I watch on TV trying to prove the heliocentric model, because there's such thing as CGI. Okay, so you said this. Oh, okay. So you showed two pictures of the horizon. You said not rising to eye level or to the middle of the picture, but both of those pictures you showed, I mean, I was looking right at him, and the horizon was right in the middle of the screen. As you were saying, that it wasn't. So I thought that was kind of strange. I don't know if you were being disingenuous or you really just didn't look at the pictures properly. Anyway, they weren't my pictures that were presented, so you might want to look at them. I don't know. Boats disappearing over the horizon. I've taken the P900 and zoomed in completely back on a boat that was supposedly disappearing over the horizon, which means horizontal. You said the water is curved on the ocean, but they call it sea level. They wouldn't call it sea level if we lived on a globe, and you wouldn't be able to give the general statement of sea level from one country to the next. It wouldn't mean the same thing. If we lived on a globe, you wouldn't have any true level surfaces, and you'd have to give your longitude and latitude anywhere to get your quote unquote sea level, which doesn't mean curve. The Aristosthenes thing, even Neil deGrasse Tyson said it would work on either a flat Earth or a globe, so that's not really that good of an argument for either side. And I don't know if that's 10 minutes or not, but I yield.
No worries. Well, thank you so much again, FlatterDay Saints, for coming out to Modern Day Debate last minute there. We really appreciate you and your introductory statement there. So we are going to move into open discussion, and a reminder to our live audience, once again, hit the like button, and we are going to do Q&A at the end of our discussion. So if you have questions, I see that there's a few popping in already. So if you have questions, get in your super chats and they'll be read with priority. So ADHD projects, I'm going to hand the floor over to you to respond to some of what you just heard, and then feel free to jump in, FlatterDay, as you please.
Okay. First thing is, I never said Globe didn't have the burden of proof. I said that we both have equal burden of proof. And then the next, you called me disingenuous on a photo. I'm going to go ahead and share my screen once again. This is a higher quality. The photo that I gave you was a low quality because when I downloaded it, I was on a network that blocked the particular site it was on, so I could only grab the thumbnail. So I have the full version of it. So if I could share my screen and see that.
Sure thing.
So.
And you're up and running.
Okay. Oh. Well. Okay. So can you see my screen?
Yes, we're looking at the...
That wasn't the photo. I was referring to the photo from the other photos you showed.
Oh, okay. Which photos
like
were
an
those?
Airplane cockpit.
Oh, the airplane cockpit. Let's go ahead and go back to those. These two?
Yeah.
Okay, so are you saying that both of these photos have the horizon at eye level?
Yeah. They're in the center.
No, so this little the little cross here in the center here, that is eye level right there.
Mm-hmm.
And then down here is the horizon. In fact, you can even see there's a little symbol saying dip of the horizon right here. So that is the dip of the horizon right there.
So the picture's basically, the horizon basically is in the middle. It's hard to tell exactly where the horizon ends and where the sky begins because it's blurred from atmospheric refraction.
Okay, so do you want to address the photo over on the left side then? If you want to, we can throw this one out. That's why I included multiple. What about this one here on the left?
Yeah, so the sea level meeting the sky is exactly in the middle of the part of the photo that's showing that's color.
Okay, so this little cross right here, showing. This is the eye level.
I mean, how do I know that though? And I mean, you could point that at the sun though, too, and you wouldn't.
So
even see
this is a theodolite. Are you familiar with theodolites?
I've heard about them.
Okay, so they're used in surveying. They're able to get perfectly level across. That's kind of what they're for.
For making a perfectly level
observation.
Mm-hmm. Oh. So then I kind of rest my case because you just said it right there. You said it's for making a perfectly level observation, not a curved observation. So you just proved my point.
Can you address the fact that the horizon is dipping down below the eye line?
I mean, like I said, you could point that up at the sun and you wouldn't see.
So let's throw those two out. What about this one?
No.
So you just nod both of these. So let's go ahead and throw those out. Let's pull up this one now.
Okay.
So what is the problem? This is a better version. What is
I
the
didn't say there was
problem?
a problem with those pictures.
Okay, so
It's a
we can
problem.
see
It would be a
that the
problem for the globe
horizon is
because
below
it
eye
shows
level.
it shows the horizon exactly level with the water levels, and
Not
water
on this.
doesn't curve.
So the one that's on sea level, yes, because that's expected, because we're down at the sea level. And then
But so
one,
you agree that the sea is level then?
I can show you a photo that says that it's not. Sorry, not flat. You're using a different definition for level than I am when I say level.
I don't know what definition are you using.
Oh, the actual definition.
The definition that says it's curved.
The definition that level, when we're talking about things on the globe, conform to the shape of the globe.
So
That's
why
what
wouldn't
we
they
mean
just say
by sea
curved?
level,
Why wouldn't they say sea curve then?
because level is like how high you are away from the globe, has nothing to do with how flat it is.
Level has nothing to do with how flat it is. Why would they name it level?
Correct.
Then? All
Because
levels
it's the
I've seen are
level
perfectly
you
flat.
are at from the for how high you are away from the globe. That's the
But if you
level.
lived on a globe,
What
there
level
would
are
be no true levels on a globe. You wouldn't have any true levels.
define? So when you say true levels, what true level are you talking about?
The level that you're measuring.
These don't measure
Water level, sea level, any level.
So water is never flat. Level means that it is conforming to the curve of the earth. That's what level means.
So
When
how
you
come
look
in
at
like the Mariana Trench where it goes down like that, it's the opposite of a globe? It's would be
because
concave,
again,
not
just
convex.
so just
Why
like
wouldn't the water
you
conform to that?
just like you say that it's not a perfectly flat pancake, the globe is not perfectly spherical. Water doesn't conform to the bottom of the container, right? When we
But
have
you just
like
said it did though.
no, I didn't say that.
You said it conforms to the surface of the earth.
It conforms to the curve of the earth.
So
So it
basically you're saying that it conforms to the curve of the earth even though it appears level, but yet when it dips down in concaves instead of convex, it doesn't conform to that.
because that's not what determines it.
But you just said the water conforms to the surface of the earth. So
It
if you're saying the earth
confirms
is,
to sorry, let me turn my camera off. Say that question again.
it was more of a statement. You're saying that the definition of level means that water is conforming to the shape of the earth, the globe, right? But
Nope,
if
that's not what I said.
okay, what'd you say then?
It conforms to the curve of the earth.
Okay,
So
but if part of that,
not just arbitrarily shape. It conforms to the curve of the earth.
yeah, not so it's not just like that. It's going like that in all directions, right? So if that were the case, then how come in the places where it's concave, how come the water wouldn't go concave?
Because it's not conforming to the surface of the earth, it's conforming to the curve of the earth.
But if the surface of the earth is curved, then it's conforming to the curve and the surface. Both of them, they're synonymous with each other.
Those are not synonymous. No. Is
So
the
the
earth
curve
flat?
of the earth and the
Wait,
curve
wait.
of the earth and the shape-
Is the earth flat? That is
is that a
yes,
rhetorical
yeah,
question?
you think the earth is flat, but you also say that there's mountains, right?
Yeah.
Okay. So when you say water's always flat,
No, I said water's always level,
okay.
or it seeks its true level.
Okay. So, I mean, it's the same thing, but when you say level, you mean flat. When I say level, I mean conforming to the curve of the earth.
Okay, but then there's my question again: is if it's conforming to the curve of the earth, why wouldn't it conform to the concave part of the earth?
Why doesn't water conform to the concave of the flat earth?
Because water is always level, no matter what shape.
Right. Yeah, I agree. Water's always level, and that level is the curve of the earth.
You're saying water's always level unless it's on a curve, then it curves.
No. Water's always
So
level.
you're saying water doesn't curve then?
No, I'm saying water curves with the curve of the earth.
But what about the concave of the earth? It doesn't
So
concave.
let me read you the level definition, the adjective of level in Merriam-Webster. It says level, adjective, having no part higher than another, conforming to the curvature of the liquid parts of Earth's surface.
So the definition. Oh wait, say the second part again. I'm sorry.
Conforming to the curvature of the liquid parts of Earth's surface. So the
Conforming to
liquid parts of
curvature the
Earth's
liquid part.
surface curve with the surface of the Earth, and this is what level is.
Okay, so why wouldn't the water also concave?
Well, why wouldn't
If
the
it's
water also
conforming to
concave on a
the Earth?
flat Earth? It's the
Because
same
water
answer.
always seeks its true level.
Correct. Water seeks its true level, and that true level is the curvature of the Earth,
And you said no part higher
not the
than the other.
convexity. You're trying to say the same thing works for you, but not for me.
No, I'm not.
Yes,
I
you
never
are.
made the claim that water changes its shape according to the surface of the Earth.
Neither did I.
You said it curves according to the Earth's curvature.
It curves conforming to the globe. It doesn't follow the Earth's curvature. The Earth and the water's curvature are both due to the same thing. Hang on 1 second. Just a short pause.
Oh, okay. Well, I'll take advantage of that opportunity just to say, once again, if you haven't already, hit the like button. We're going to keep the conversation rolling. Unfortunately, ADHD had to step out for just 1 second, so... and it was literally a second, just enough
It
time
was.
to switch up the screens there, so let me just get everybody back where they were. Boop-a-da-boop. And let's carry on, gents. All right, if you wanted to go ahead there, FlatterDay Saints, and maybe shift gears into another topic, that might be a good idea. I think we might have explored this one.
Okay. Like Dora?
Oh no, I was gonna say I can't start singing on the stream. I got PTSD from having children for as long as I have, right? So
Yeah. Right.
they're getting older now.
I don't know if you wanted to talk about Aristophanes, whether you said it didn't even matter whether he was a real person or not.
Correct. It doesn't matter if Eratosthenes himself existed. The experiment outlined when we say the Eratosthenes experiment is still a valid experiment.
Well, wouldn't that if that wasn't a real person and they're saying it is, wouldn't that nullify the whole experiment?
No, because we can do the experiment separate from him. The experiment that I brought up had nothing to do with Eratosthenes himself. It is the style of experiment that I was referring to, not what Eratosthenes did. I was referring to what people modern day did.
So what if you did the experiment on you measured, you took a measurement and you flattened out a good chunk of Earth, let's say like an acre, right? It was completely flat and level, but flat nonetheless. And so you did the experiment on that, and there was no curvature whatsoever that the shadow hit. Would the experiment still work just the same?
So is it flat or is it level? Those two things are not the same.
Well, no part higher than the other.
Okay, so no part higher than another, like level as in conforming to the curvature of the Earth, right? Is that what you're asking?
No part higher than the other. There would be no curvature because
Oh no, because height on the globe is determined by curvature. As long as it's like elevation that follows the curvature of the Earth.
Elevate. So remember when I said if you were on a globe, you would never have any you wouldn't have a common word or common theme, which is sea level, and it's the same. Sea level is the same no matter what part of the Earth you're in. They use it to measure building, how high building is, bridges.
So sea level is not the same no matter where you're at. The level that you're talking about that we use to measure how tall buildings are and things, that is an average for sea level, because sea level is different depending on what part of the Earth that you're at. Sorry, my cat is screaming to be let out, so I'm going to let him out.
Mm-hmm.
No worries. I think
For all the kids out there, I'm drinking out of my baseline glass, my uranium glass.
Your uranium glass.
Just letting you know.
That's cool. I was gonna say,
I love your pressure.
I'm drinking from a can. Maybe that's a bad idea. I don't know. I was gonna pour into a
Sorry
little
about
Depends on
bit,
that.
what you're drinking.
but all right, no worries. It happens. You know, cats need what cats need. So let's carry on and try to keep focusing on this one here.
Okay. So again, we're coming back to the whole, if things follow the shape of the Earth, do they rise and lower, right?
Yeah.
Okay, so when we measure elevation, this elevation is based off of the curve of the Earth. Okay, so we have this agreed upon sea level, which is the average height of the oceans throughout. I don't know, actually no, it's average something. It's an arbitrary
Mean
number
sea
that
level?
what?
Talking about average mean sea level?
No, so the average just sea level, because sea level is always raising and lowering, and tides exist, and sea level is different depending on where you're at, which disproves the flat Earth. But it's an average levelness, and then when we go up from that average wherever we're at, that is how high it is above sea level.
So if we lived on a globe with no true level surfaces and everything was curved, then
Again,
there you have
level
to give
means
your
following the
longitude and
shape of the
latitude.
Earth.
Huh?
So level again means following the shape of the Earth. So there is a true level that is the in concordance to the shape of the Earth.
So I don't believe that something that means no part higher than the other could possibly mean that it's following the shape of a curved Earth. That doesn't even make any sense.
Because higher than the other means distance away from determined sea level that is concurrent throughout the entire globe.
So let's say the sea level in the city of Los Angeles, right, would be different depending on what part of the city you're in.
That is why we have an agreed upon sea level that we go off of.
Or maybe everything is just really level.
No, because it's even on a flat Earth, the sea level changes no matter where you're at. That's just a fact. Sea level is different depending on the time of day that you are, depending on your latitude and longitude, depending on whether you're in a canal or whether you are on the ocean itself. This is just a fact of life. That is why we have an average sea level that we go off of, that everyone has decided that is sea level.
Wait, why would sea level change according to how high you are?
It doesn't change according on how high you are. It changes on where on the globe you are because of things like the tides and currents and things like that. It changes the height, the how high sea level is. It changes no matter where
Yeah,
you're at. This is
yeah,
just a fact
yeah. So, but why wouldn't that work on a flat Earth too? Why couldn't water rise in
because
sea level
water always finds its level.
as it's rising and going lower?
It doesn't rise altogether.
All right.
The water doesn't rise altogether.
No, not across the entire world. It is always bending.
So, if
It's
you guys
always
had any
bending.
closing thoughts on the discussion around level, the levelness of water, you know, maybe we could, like I say, shift gears into some different territory because it seems like we might be just going in a circle on this one. So
We moved and then we circled back to what level was.
it happens. It's
Like the
okay.
hands on the clock, they did a circle.
No
Correct. They
worries.
they did a circle.
Yeah.
Yeah. So I just closing level means the shape of the Earth, um, whether or not
So
it's
you're
flat.
saying the Earth is level then?
Correct.
Okay. Well, then, I mean, I don't. You pretty much just proved what I was trying to say. So
No, because level means the shape of the
All right.
curve of the Earth.
All
That's
right.
level.
Like I said, we're
Okay.
gonna keep
We
going in
we
this
can move on.
circle. Let's move along. Yeah. Yeah. It seems like you got something on your mind there, ADHD. A different place you want to go there. So if you want to push us into a new territory, feel free.
Okay. We can go on to Southern Star Trails. Southern Star Trails disprove the flat Earth. When you are in the Southern Hemisphere and you look south, looking at the center point wherever south is directly, there is a point that all stars will rotate around. They will rotate in a clockwise. I can't remember. They will rotate around the central point. And that is impossible on the flat Earth, or at least I have never seen anyone be able to explain how southern star trails work on a flat Earth.
So remember I said about the zodiac wheel that they still use that's still based on a flat Earth model?
That has nothing to do with what I just said.
So it does have to do with what you just said, because the way the zodiac wheel works is with the star trails, with Polaris right in the middle, like a dartboard.
So the
It's
zodiac
perfect
the zodiac signs travel across the sky like this. In the southern,
just like the stars, they make everything goes in a circle in the sky. The stars all go in a circle.
it goes around in a circle, correct, in
Yeah.
both hemispheres. That's okay in the north. If you look north, they go in a circle around the pole star. If you look
Okay.
south, they're also going around the southern. There is a star around that area. You just can't see it with the naked eye. So it goes around a southern point, also in a circle. This doesn't work on a flat Earth.
Why wouldn't it work? It could work on either model.
Can
Actually,
you
it wouldn't
show
work on
me?
a globe
Can you
because
show
wouldn't
me?
have Polaris in the middle. You would never have any star in the exact center.
Don't deflect away. We're talking about the trails itself.
Yeah, I was talking.
Can you
about
show me
Polaris.
how it works on a flat Earth?
Just look in the sky. You'll see how it works.
That didn't.
I don't know how I could show you besides saying just go and look at the sky at night.
Right,
I
I look
can't
at the
hold the
sky,
sky
and
down here
that's
and
that's
look.
how we know that the southern star trails exist and make circles in the sky. The fact that
Okay,
they're making
so-
a circle around so think of the flat. So you've got flat Earth.
So why
right?
couldn't the flat Earth be a circle?
Flat Earth is a circle, but the sky.
I don't know
is,
that. I'm not making that claim. I said it would be you would think it would be by the star pattern. I'm not making a claim that it is circular. I personally believe it is circular, but I can't prove that.
Okay, how do stars move on a flat Earth?
I don't know how would stars move on a globe? Do you know how they move? Nobody will really know how a star moves. We can only say the direction they move. We don't know
They
how
move because the Earth is spinning. That's why they're making the
why
shapes
would the
that
stars
they do.
move? Why would they move just because? So if the Earth wasn't spinning, the stars wouldn't move.
Correct.
Really?
Okay, so let's do a little experiment. Pretend your head
I'm moving a
is
little
globe.
closer to your mic, so sorry. If you can move a little
Sorry,
closer
that's-
to your mic, FlatterDay, just because you're
Oh,
coming
yeah,
in very
sorry.
low. It's okay.
Yeah.
Carry on. Sorry to cut you off.
Okay.
Okay, so let's do a little experiment. Let's say your head here is a globe. Okay, your eyes are your perspective. If you look straight and keep looking straight, but turn your head, do you see how the room moves? The room is moving because you're turning your head, right? If you're able to keep it, it's really hard to keep it straight. So like if you turn, the room will move across your vision.
Okay.
If you don't turn your head, the room will not move. Same with
That's not
the
a really
globe.
good. That's not a really good example because that would be like we're moving with the Earth the way the Earth. You know what I mean?
We are
That's not
moving
even-
with the Earth.
But we're not the Earth though.
We are on
so
the
you
Earth.
said
So
if our eyes were the Earth.
your eyes are your perspective. When the Earth spins, right? We're standing on the Earth, and as it spins, we kind of move with it, right?
I don't think the Earth is moving.
In the globe Earth model, right?
Yeah.
Okay. So that's the same with your eyes. When you move your head, your eyes move with your head. The motion
are the
of the
stars
room
moving
around
then?
you. What?
Are the stars moving? Are the stars
Um,
moving? Are there stars moving separately from the Earth?
They are, yes.
Okay, so if the Earth wasn't moving, would the stars still be moving?
We would not be able to see it. We could take probably a photo every day. I mean, there wouldn't be days if the Earth wasn't spinning, but there would be slight shifts. But it's like less than a degree over like 50 or 60 years,
And how could you know that?
because we've mapped out the stars and where they are in relation to us. We're all spinning around the Milky Way galaxy. And so the stars do slowly drift from night to night. It's just really, really small. We've tracked it.
Wouldn't you need a third point of reference to know how far away a star is or how fast it's going?
No. Well, so yes, technically, but we do have 2 points on Earth that we can measure from. If we measure from one side of the Earth, measure to the other side of the Earth, and then point at the star. But we've moved past star trails. I want to get back to star trails. So in the southern hemisphere, when we look south, so on a flat Earth, we're looking south. We're looking in different directions, right?
You mean like the south as being like the Arctic Circle? Or
yeah. So south would be Antarctica around the outside, and we're in Australia. We look south, and we're looking that way. In Africa, we look south, and we're looking that way. Right? They're 2 different directions, right? Because if they're not, it's a globe. If they're looking in the same direction, it's a globe.
Well, if we lived on a globe, there would be no north and south. I mean,
That's
everything would be basically a curve. You know, how would
correct.
you get
yes. Okay. Oh yeah. So we have arbitrarily decided what north is.
Arbitrarily.
Yes.
Why do you think that's of arbitrary?
So what we've decided is north is what our compasses kind of point to. It's based off of how we oriented our maps.
So that's not arbitrary.
It's arbitrary in we could just decide today that Washington, D.C. was the North Pole and oriented all of our globes. So Washington, D.C. was on the top and everything else was around it. And then you would get like Australia as the South Pole. It's an arbitrary thing that we've all decided on.
That wouldn't work with a compass.
You're right. It wouldn't work, which is why we've decided that the North Pole is the North Pole, is because the Earth does have a magnetic field.
So the way the compass is like a clock, basically.
The compass is nothing like a clock.
It's not flat and round.
Well, I mean, if that's the case, lots of things are like clocks.
Yeah, a lot of things.
But it doesn't work like a clock.
It doesn't work like a clock.
A compass, no. The compass just points to the magnetic north.
Yeah. So with hands that appear like clock hands.
Right. And so on a flat Earth, we're standing in Australia. We've got our little compass, and it's pointing to the center, or wherever you think north is. Here, before we get into that, what is the flat Earth? Because remember, in a debate like this is in debates like this, both sides have equal burdens of proof. So what is the flat Earth model that you are defending?
I'm not defending the flat Earth. I don't need to defend the flat Earth because it's basically what all our senses tell us. You know, your senses, from all outward perspectives.
Okay, so what is the flat Earth that your senses tell you it is? Describe what. If you were to sit down and say, this is the features of a flat Earth, it would be?
What we observe every day, what I observe every day.
Where's the North Pole?
I don't know where the North Pole is. I assume it's somewhere right in the middle of the Earth where the compass is pointing.
Okay. Where's the South Pole?
I assume it's around the circular edge.
So anywhere that you look in the southern hemisphere, if you look towards the edge or whatever you just said it was that south is, you're looking in different directions, correct?
I'm not sure. I've never been to the southern hemisphere.
But that's what you just claimed. If north is in the very center, if you look anywhere else in the southern hemisphere, that's south. That's away from north. If you look,
I guess even if you're looking north, technically you're looking south. You know, if you consider the south the ring, the ice ring.
Right. Yeah. So, but on a flat Earth model, when you are looking south in Australia, we see the stars making circles in the sky. Can you explain how that is possible on a flat Earth?
I don't know. I've never been to the southern hemisphere.
Okay, I know people that have, and I showed you photos of it, and there are time lapses of it. I know people that have done it. My father has been there. I am going there in December. So this is a fact that stars rotate around a center point in the southern hemisphere. Is that something that your model can defend?
Well, you just said the stars rotate around a central point. So on a globe, if we're spinning on a globe, the stars would have to be going like that in exact unison.
And that's the North Pole. Yes. So I
that-
agree. So I agree. In the north, when we look north, there is a center point that all of the stars would be rotated around. That's great in both models. That's great. Perfect. We agree. Where we do not agree is in the south. When we go south, they're also rotating around a central point. This is a different point than the north. In fact, we have to turn 180 and look the other direction in order to see this spinning around a single point. That's why I showed you the picture of the star trails. They had two sides with two central points, and then the stars would go around it. That was taken from the equator. So in the south, verifiably, we know that this is true. Stars rotate around a southern point that is opposite of the North Pole. They're different sets of stars. They're not, it's not Polaris, and it's not the Big Dipper rotating around Polaris. It is Sigma Octantis and the Southern Cross rotating around it.
Okay. It still doesn't, that doesn't prove whether the Earth is flat or spherical.
It absolutely proves that it's a sphere.
How could something in the sky prove the shape of the Earth that you're standing on?
Because it's an observation made based off of what we are standing on.
How are you making an observation on what you're standing on if you're looking at the sky? That's not observing what you're standing on.
It's based off of what is happening underneath our feet. The only reason that you're saying, well, how can we, is because it destroys the flat Earth model. The reason you can't address it is because it's something that the flat Earth.
I'm only claiming what we see.
And I'm claiming what we see. And we see stars rotating around a central point, which is impossible on any version of the flat Earth that I have ever seen.
Well, I don't know what versions of the flat Earth you've seen. I'm not claiming any version. I'm just claiming what's obvious and apparent to all our senses.
Right. And what's apparent to our senses is that anywhere that you stand in the southern hemisphere and looking towards the center point, stars rotate around that singular point. No matter where you stand, if you stand in Australia and look south, they're rotating around a single point. If you stand in Africa and look south, which should be a different direction on a flat Earth, if it's not a different direction, it is a globe.
Even if we did see parallax, it still wouldn't prove whether
that's not parallax.
No, I'm saying we don't see parallax. There's no parallax.
That has nothing to do with the rotation of the stars around a singular point.
Well, the shape of the Earth has nothing to do with the rotation of the stars around the Earth.
Yes, it does. The only reation that you say that is because it disproves the flat Earth.
No, the only reason
it's like that movie Don't Look Up.
I don't know about any movie, bro. I don't really watch movies, but I just know that the stars don't prove the shape of the Earth. The stars are moving independently. You also agree with that, whether the Earth is moving or not.
So the stars do move independent, but we can also remember our turning our head example. If I turn my head, the room moves.
Yeah,
that's what's happening. So, if the Earth was a globe and rotating, stars by necessity would have to be moving in the direction that we see them.
Why would they have to be doing anything? Who says the stars have to be doing anything?
Because when you move, the objects around you appear to move.
They appear to
based off of the direction that you are moving.
Mm-hmm. They appear to.
Correct. When you turn your head, your room isn't actually moving.
Yeah.
Right, and that's how rotation.
So the only way you could, I've figured the only way you could determine the shape of the Earth from the stars is if all the stars were connected to poles that were verifiably straight in the sky, and you knew how far away they were. Then I think only then you'd be able to tell the shape of the Earth by the stars. But there's nothing connecting the stars to the Earth; they're independent of the Earth.
But we know that the stars are rotating in the way that they are rotating, right? Either on a flat Earth, they're rotating in a dome around the center point, which we both can agree on, or on a globe, as we spin, the stars spin. Now, the thing is, yes, you could be right. The Earth could still be a globe and the stars just moving around us. But the thing is, it disproves the flat Earth. Every observation that we make of the sky, which is why flat earthers are conditioned to say, well, you can't prove the shape of a table or you can't prove the shape of a billiards table by the balls on the table. It's because the flat earthers are conditioned because when we look up at the sky proves that the earth is a globe.
It doesn't prove anything. The earth could be a pyramid. It wouldn't prove one way.
We wouldn't see that on a pyramid.
How do you know if you've never been on a pyramid?
Because I can model a pyramid and say what we would expect based off of a pyramid. I can model a flat earth.
So what about if you model the star trails and like use the zodiac calendar, which is based off of a flat earth?
The zodiac calendar isn't based off of a flat earth. That is an incorrect
circle
statement.
No, it is based off of a flat earth.
Nope.
Oh,
Because
really? Show me where it says it's based off of a globe.
Show me where it's based off of a flat earth.
Okay. I don't know if I can pull it up or not, but I mean, this is just common knowledge to anybody who knows anything about the zodiac and who's
when you are born, the zodiac that the sun is in at the time of your birth is what it is. Okay, when we're standing on Earth, we look up at the zodiac, and the sun is also it rises in that zodiac. That's what it is. It's not based off of a flat Earth.
They match the sun up. They match the sun's day course with the night course.
Based off of what we see in the sky. It has nothing to do with a flat Earth. It's based off of what we see in the sky.
So it definitely doesn't have anything to do with a globe. You couldn't have that on a globe.
No, you can have that on a globe. Why couldn't you have that on a globe?
I guess if the globe wasn't moving and the stars just rotated around a central point on the globe, I guess you could.
No, I want you to explain why we couldn't have that on the globe. You made a claim. Go ahead and back it up.
And I'm saying unless the Earth was stationary and the stars moved around a central point, you couldn't have it.
Okay, now explain why you couldn't have it.
Because like I said, it would be like gluing a GoPro to a basketball, spinning the basketball on your finger, then going on a roller coaster ride and looking at the video footage afterwards. You never see the same thing.
That's an incorrect analogy because the amount that we move from day to day is nominal based off of how far away the stars are, based on what we have measured the stars to be.
How have we measured the stars? You can't see how far away something is unless you have a third point of reference.
We do have a third point. We have the star, and then we have 2 points on the globe. That's a
three-body problem. You can't have.
That's not a three-body problem. Variable. Do not invoke the three-body problem without knowing what the three-body problem is.
You don't have an independent variable. You can't have both measurements from the Earth.
That has nothing to do with an independent variable. It is a triangle. Are you disagreeing with all of geometry or trigonometry?
Geometry is the measurement of
shapes
of the Earth.
Shapes.
Okay. Well, the Earth.
Right, but geometry is the measurement of shapes.
The measurement of the Earth.
The shapes. Geometry.
Yeah.
It's not the measurement of the Earth. It's the measurement of shapes. All geometry.
Right. Okay, bro.
Okay, bro. Do I need to look up the definition of geometry? Do you want me to do that and share my screen?
It cut out for a second. I couldn't hear the last thing you said.
Do you want me to look up? Okay, so geometry, a branch of mathematics that deals with the measurement, properties, and relationships of points, lines, angles, surfaces, and solids.
Okay. So that sounds pretty much like the surface of the Earth.
Okay, so the surface of the Earth is a geometric shape, but that is not what geometry is. Geometry is a branch of mathematics that deals with the measurement, properties, and relationships of points, lines, angles, surfaces, and solids.
Okay.
That's geometry. So based off of trigonometry, which is the same thing but specific to angles, or to triangles and angles, I guess. We have star, we have globe, we have 2 points on the globe. We know the distance between these 2 points, and then we can see the parallax, the angles to the star, and based off of those, we can figure out how far it is.
You could not figure out how far or how fast it's going unless you had a third reference that wasn't on the Earth.
That is incorrect. The third reference can be on the Earth.
No, it's just the same as the first reference.
Explain why not.
Because it's okay. So your third point of reference would have to be not on the star or the Earth. It would have to be somewhere in between.
So I've got me standing on the surface of the Earth, and I've got someone else standing super far away on the other side of the Earth, and we're both looking at the same star.
You still wouldn't be able to tell how far away it is.
Why?
Can two people, one standing on one side of the freeway and the other standing on the other side of the freeway, tell how fast or how far away a car is?
They can tell how far away it is, yes.
Really?
Yep.
Two people can.
Yep. If they knew if they knew the distance between each other, the angle to the car.
Actually, I'm sorry. Let me rephrase that. Okay, so two people on Earth looking at an airplane, something that's not on Earth. I gave a bad example because I gave an example of three things that were on Earth, which is.
But this is something that you can do on Earth.
Yeah. So, anyways, I meant something that's in the sky moving. You couldn't tell how far away it is from just another person's perspective.
At a singular time, we could tell how far away it is. Yes.
No, you'd have to have something independent of the plane and the Earth. The third.
That is incorrect. That's incorrect because we have 3 points. That is 3 points of a triangle. We know the distance between these two people. We know the angles to that third point based off of trigonometry. We know we can calculate that distance to that star.
It's not true. There's no way they can do that.
It's true. Yeah, that's trigonometry. It's the same thing as two people standing on opposite sides of the freeway looking at a car. They make an angle to that car.
I gave a bad example. Like I said, it would be like an airplane trying to look at an airplane.
Same thing.
Seeing how far away it is,
they can still do it. They can. So again, they can see how far away it is.
It wouldn't matter if you had 1 million people all looking at the airplane. They wouldn't be able to tell.
1 million people would make it harder. It's easier with just 2.
Like I said, you need a third point of reference that's neither on the airplane nor the Earth.
We do have a third. So it can be on the Earth. That's fine. It still is a triangle.
And so what instruments did they use to measure how far away the stars are?
Protractor. The angle they can just measure the angle of it.
With what though? What did they use to measure it?
So I've seen it done with like a measuring square. You can measure the angle based off of that. It's just anything that you can look at and get an angle from. You say, here's my point of reference. There's the star. Here's my angle towards the other person.
You can't tell how far away the star is by that, though.
You can if you add a second person who also knows the distance. So I'm here, and then there's someone here. We're looking here. I know the distance between these two.
You don't know how far away it is.
You're correct. But if I know this distance, and I know these two angles, I can calculate the distance between these 2 points. How
could you know how far away it is? What instrument would you use to measure that?
You would calculate based off of the things that you can measure. This is the entire study of trigonometry.
Yeah, so like I said, there's no instrument that you could use to measure how far away a star is, bro.
You calculate it based off of the things that you can measure. This is trigonometry.
This is just all theoretical, though.
It's not theoretical. We have proven that it works. These are
nobody's ever been there and chalked the distance of how far away they had to fly.
Because anytime we do it on, so it's just a fact of how triangles work. How many degrees are in a triangle?
It's theoretical, bro. It's not. There's no fact. Nobody can know. It's
you don't know. Okay.
It's unfalsifiable, bro. What you're saying is unfalsifiable.
No, just because you don't understand it and can't falsify it doesn't mean that it is unfalsifiable.
Sure, it's unfalsifiable. There's no way anybody could know how far away a star is.
Okay, so if I am standing here on Earth and someone is standing 10 feet that way, and we know that there's 10 feet in between us two, and we know that when I look at him and then I look at the thing I'm looking at, that is a 45-degree angle. When he looks at me and then looks at the thing that he is looking at, that is also a 45-degree angle. We can use the 10 feet and the 2 45-degree angles and measure the distance to that object. It doesn't matter how far it is, we can calculate that distance. That is a verifiable thing. If I do it and then calculate it and then measure to verify that I've calculated it correctly, I could then do a trigonometric proof to prove that that works anytime you have a triangle, because there are specific properties of a triangle that are always true no matter what.
Okay, so anyways, That's not true. You couldn't measure how far away a star is, and not just
So
that, but
you can't do it, but you don't know why you can't do it, and you
I'm
can't
explaining to you why you need a third point of
address the
reference.
trigonometry.
No, I'm saying you need a third. You don't even know what they measure how far away a star is, bro. You don't even know what instruments they use because there is no instrument that they can use.
They take two angles. They take an angle from one person to the other. That's angle one. They take another angle from one person to another. You can there's multiple things. You can use a protractor to measure that angle, and then you can take a tape measure, measure that angle or the distance between the two, and then
So you think
use
they used a protractor in a measuring tape to see that the sun was 93 million miles away?
no, they bounce the radar off of it.
So they used a radar. What type of radar did they use?
Radar, I don't know. I'd have to look it up.
I mean, since this is the model you're representing, you might want to know the facts of.
But you didn't know what south was. Why is it that you don't have to say what south is? Yeah, exactly. You said you didn't know. So why is it that you are holding my standard of evidence to a higher degree than you? I can easily go look up the experiment that they bounced the radar wave. In fact, you can do it with a ham radio. And at least you can do it.
Then why wouldn't cell phone signals go forever? There's the propagation of electromagnetic fields over a flat Earth, bro.
The curve of the Earth.
Well, it's actually a book from Army Research Laboratory. It's called The Propagation of Electromagnetic Fields Over a Flat Earth. You can Google that and find it.
Yep. So why don't they go forever if it's a flat Earth?
Because signals just don't go forever, period.
Oh, that is incorrect. That's incorrect.
No, it's not incorrect. Signals die out. They phase out.
Not if there's nothing for their energy to deplete.
So you're saying a signal goes just as strong as when it's sent as when it gets to where it's going?
It depends on the mediums that it's going through. If I'm sending a signal from
the medium is air. It's going through the air.
Not in space. So when
you're invoking something that is unverifiable.
That's not we have verified it.
And it's basically then it's just theoretical.
We have verified it.
You haven't verified it, and I haven't verified it.
Okay, science is
You've been told it's been verified.
I mean, so are we going to throw out all of science yet? You invoked radio propagation over a flat Earth. How come you didn't have to verify that, but I have to verify something?
Well, I'm saying I'm things that you haven't verified. Google it and verify it, though. I am verifying that there's a Army Research Laboratory book called The Propagation of Electromagnetic Fields Over a Flat Earth.
Great. There's a book called Harry Potter. So just because a book says it, I mean, I haven't read that. I vaguely know what it is, but I can't remember exactly what it is. But you haven't verified radio waves propagation on a flat Earth. Yet you're invoking that book. What is the difference between that and what I'm saying on bouncing a ham radio off the moon?
Because that's almost laughable, bro. Bouncing a ham radio off the moon. You said the sun, but even the moon. How do you know it's bouncing off the moon?
I know that you can do ham radio bounces off the moon. I don't know if you can do it off the sun. You might need more specific things for the sun, but they have bounced radio waves off of the sun.
So how would they? What if the Earth had a dome over it, right? And they bounced radio waves just off the dome and it came back?
Because we know how fast radio waves travel, and if they bounced off the dome, we would get like 3,000 miles, based off of how fast radio waves travel. That is a known speed.
Mm-hmm.
And when we send it off, we start a little timer, and then when it gets back to us, we click off the timer. Based off of the speed of radio waves, we know the distance that it had to travel there and back.
How do you know you're receiving the same signal back? And when have you ever verified this?
When have you ever verified radio wave propagation over a flat Earth? You have invoked things that you haven't verified.
I'm not making any positive claims, though.
Yes, you are. The Earth being flat is a positive claim.
The Earth is observably flat, though. I'm just making an obvious claim.
That is a positive claim.
It's obvious and observable.
It's obvious. It's a sphere. You have the positive claim. Remember,
you're being intellectually dishonest. Then.
No, I'm not.
You're saying that you witness the Earth as a sphere. That's how you look at it when you look at the Earth.
Yep.
Really?
Yep.
You're being dishonest, bro.
Nope. See,
Okay.
yeah, I can do it too. I can just say things and say, no, I have seen that it's a sphere and therefore I don't have to say anything.
I mean, where would
So
you see the curvature from? Neil
I've seen
deGrasse
star
Tyson, you said you
trails.
can't even see it from 120,000 feet. He said that stuff is flat.
So Neil deGrasse Tyson is being misquoted there. And he also likes to say things like you can't thump sand when talking about Dune. And it's been proven that you can. So Neil deGrasse Tyson has said things in the past that are wrong. He says things for shock factor. That's his whole thing. In fact, I have debunked Neil deGrasse Tyson several times.
I'm sure
He
you
just
have.
says things. Yes, it is pretty flat based off of where Baumgartner jumped off of. He was saying that it isn't super curved because they were using a fisheye camera. That does not mean that you cannot see the curve of the Earth from there.
So how you've seen the curve of the Earth from what elevation, or just from standing on the ground?
I didn't say I saw the curve of the Earth.
You said you witnessed it as you witnessed curvature
Yep.
or a spherical.
Yep.
So where did you witness curvature at?
Where did you witness flat at?
It's observably flat. When you look at the ocean,
Did you
when
measure
looking
it?
in any direction. Huh?
Did you measure it?
How can you measure flat? Flat's
How-
not a shape.
I mean, absolutely. A plane, that is a shape. And you said that water is always flat and level. That is a shape.
No, I said water always seeks its true level.
That is a shape.
Level is a shape.
A plane is a shape.
Yeah, an airplane is a shape. Yeah.
No, not an airplane. A geometric shape of plane.
How could a
Shape.
plane be a shape if it doesn't have top parts? How can a shape just be a line?
It's not a line. It's 3 points.
So then you're measuring the air then.
So you are stating that you cannot verify that the Earth is flat, right? Is that what you're claiming? You can't
No,
measure flatness.
I can't verify that the Earth is a globe.
You
There's no way for me to
but
verify
you
that.
said you can't measure flatness. You can measure.
How would you
curve.
measure flat? Yeah, true. You can measure curve.
Right.
If there was a curve, you could measure.
You try and measure curve, and then it doesn't measure.
So Earth isn't measured as a curve. Show me any measurements that show the Earth is a curve.
The Eratosthenes experiments done shows the measurements of curve.
Eratosthenes.
Mm-hmm.
Even if it was on a flat surface.
It not on a flat surface. No.
What if they made it a flat surface that they measured it on? Would it still work?
What if it doesn't matter? That's what they've measured it. Your what if doesn't matter. It is they measured it from 3 points and saw that it is a globe. Or we could go and take theodolites and point them together and get reciprocal zenith angles. Reciprocal zenith angles also measure curvature.
So you're saying with the triangle, you're able to measure curvature.
Not a triangle. Reciprocal zenith angles.
Explain.
Okay, so reciprocal zenith angles. So I'm here, my buddy's here, and we find perfect plumb. Do you know what plumb is? When we say finding a plumb level?
Yeah,
Like a plumb bob?
Yeah. So how could you? So a plumb bob is
You put a little weight on the string and it goes straight down, right? That
Yeah.
verifies that it's down.
So it's perpendicular.
Right. Yeah,
Right.
perpendicular to the
The surface of the Earth.
surface of the Earth. Correct.
Okay. How would you ever have anything that's completely perpendicular to a curve?
Perpendicular to the tangent. Yeah, that's fine.
No, I mean, I'm saying if the Earth is curved, you wouldn't have any perfect perpendicular line. You wouldn't be able to use it.
That's incorrect. You can.
Yeah, you
So
can because
at a single
there's
point,
no
you
point.
have what's called a tangent. Do you know what a tangent is?
a single point.
No, a tangent isn't a single point. So tangent is a line. So you have a circle, and then you draw a line, and the tangent only touches the circle at one point.
Mhm.
Okay, a plumb bob is
So-
perpendicular to that tangent line.
Is the line straight?
Yes.
Okay, so then you're verifying what I'm saying. Then.
No, because it's perpendicular to those tangents. So
you never have any straight
another
line
way
on a
that you-
curved surface.
Correct. You're drawing a straight line that intersects the curved surface at a single point. That's
straight
called a
line that
tangent line.
intersects the Earth's curved surface.
At a single point.
Why would you need to draw a straight line though? If the Earth is curved, why would you even use?
Because
straight
the Earth is curved.
So that's why you draw straight lines to measure it.
So we're not drawing an actual line. So another way to think of a plumb bob is you've got a little weight and it's pulled by gravity towards the center of the Earth. And at the singular point, that is going to be perpendicular to that little section or that tangent line of the
Where's
Earth.
the center of the Earth, though? If the Earth is a ball, there is no exact anywhere would be the center. You could say anything's the center.
It's in the.
Are you talking about the center core?
Yeah, the center.
How do they know where the center core is if they've only dug supposedly 7 miles into the ground?
So you're deflecting away from reciprocal zenith angles. Do you want the measurement of the Earth or not? Because I can address how we know where the center.
I don't believe anybody can measure the Earth. I think the Earth is immeasurable.
So you don't want the measurement of the Earth that multiple people have done.
Well, are you going to give me the heliocentric measurement of the Earth?
The measure I'm going to give you a measure of
the
curve.
Circumference is.
I
So
mean,
you're talking about like the Pythagorean theorem, which is like 8 inches per mile squared.
that's not the Pythagorean theorem.
It's
We
not?
we went over the Pythagorean theorem. You not the Pythagorean theorem.
I don't
That's
think
how
you
we
ever brought up
use
the Pythagorean
triangles
theorem.
to get distance. That's the Pythagorean
No, that's
theorem.
Aristophanes, though. That's different. That's
No, that's not Aristophanes. Aristophanes used the shadows. When you were saying how do you get the distance to the star, that's using the Pythagorean theorem to get that distance.
to the distance of the sun. You mean?
Or we were talking about stars, and then you brought up the sun, and then we went to actual measurements of curve. Would you like to hear the measurements of curve, or would you like to move back to the Pythagorean theorem that you are?
I'm just wondering, how did Aristophanes know if they didn't have clocks back then that weren't sundials, which only work on a flat plane? How would they know when high noon was for one person as for the other person in a different town?
Because they measure, because it was when the sun was highest in the sky.
How would you know when it's highest in the sky?
By looking at it.
Yeah, but that would be different for anybody, in a different
right. So that's why it's important that. So for Eratosthenes, and
without
remember,
a clock, though, how would they know the exact
I don't
minute?
care if Eratosthenes existed or if he ever did the experiment. I don't care about that. I don't care in the slightest. Eratosthenes could be fake. He could be made up by history. I don't care. His experiment could be extremely flawed. In fact, I think it is flawed because he only used 2 points. I am talking about modern day versions where we measure and we can say, hey, is the sun up? Or we can say, hey, take your measurement now. So it doesn't matter.
They didn't have
it doesn't
phones
matter
back
if
then or
Eratosthenes
clocks. How would
actually
they
did
know
an
the
experiment.
exact? But wouldn't the exact minute count for that experiment?
It doesn't. So yes, it would matter.
So
And
how would
that's
they
wh-
sync their? How
That's
would they
why
sync their
I'm not
time?
invoking Eratosthenes himself. This
No,
experiment.
I'm not even talking about him though. I'm talking about the experiment. How would they know? How would the two people in different cities know the exact time? With a cell phone?
Yeah, they can talk. They can talk on the phone to each other. So right now, me and you, we're talking. There is a little bit of delay because we're using the internet.
Okay.
Phones have
So
much
when have they
quicker-
ever done that experiment with their phones like that and been able to see how far away the sun is from stick shadows?
It's been done several times. People have done it on YouTube. People have done it live. MC Toon has
That's
done it.
laughable, though. It's not even.
So
that's not
nuh-uh
even
then.
real.
So nuh-uh.
It's
You said
laughable.
when is it ever done, and then you said it's laughable that it's been done.
It is.
Why is it
It's-
laughable?
Because it's just theoretical.
It's not
it's just taking
theoretical. They
guesses.
did it. They did the experiment.
Yeah.
Do you disagree that they did the experiment? Are you calling
I
them a
don't know.
liar?
Who's they?
So there are several people that's done it on YouTube. I can't remember his exact name. MC Toon has also done it. I pulled up this Michigan paper and showed you the conclusion based off of doing it.
Mm-hmm. It's still theoretical. You need a third point that's not on the Earth in order to see how far away something.
That's where when.
Let alone
why
the
are we?
curvature.
That's not what we're talking about. We're not talking about how far away the sun is. We're talking about the curve of the Earth. That's what the Eratosthenes experiment did.
Why would looking at the sun though determine the shape of the Earth?
Because how the shadows fall on the Earth. So
That could
if
also
we've-
work with a local sun though. It could.
That's
work on a
why there
flat
has
Earth
to
with a
be
local
third.
sun.
That's why there has to be 3 observers. That's why I think the Eratosthenes original OG Eratosthenes himself was flawed because he only did it with 2. Because it can work on with 2 people, What it cannot work on is 3. That's why specifically in my slideshow at the beginning, I said angles of measurement to the sun from 3 observers. It has to be 3. If it's only 2, you can say it's with a local sun. If it's with 3, you can no longer say that.
Why couldn't it be with a local sun with 3 people? Or with 5 or 10
because when you get, so you can say we're on a flat earth and the sun is super local and we're getting 2 measurements, or you can say it's curved and it's super far away and you can get the same 2 measurements from those 2 people if you vary the size of the sun. So when you get 8, that's why I brought up third. That's when you get a third person. That's when it no longer works on both. Because a third person on the flat earth will get you a different angle than a third person on a globe because it's much further away.
I mean, we don't even know what the sun is, bro. We don't know if it's just
that doesn't matter to the experiment.
What do you mean it doesn't matter? What if the sun's not even a solid thing?
That doesn't matter. What if it's not?
What if the sun is really a lot closer than we think?
That's why we do this experiment.
I mean, the crepuscular rays prove with geometry that the sun is local.
No, they don't.
They come out like a pyramid.
They look like a pyramid.
So it's just appearing to us as a pyramid. It's not. Really,
just like train tracks.
The rays aren't really crepuscular.
Just like train tracks.
It's just like train tracks.
Mm-hmm. Yeah, when you stand in the middle of 2 train tracks, they're going to go off in the distance and make a triangle. Same thing. Train tracks are parallel.
Okay, bro.
I've seen photos of people sitting in front of a window, and the crepuscular rays are coming from the window, and some of them are coming up, and some of them are coming down, based off of your same.
Because it's going through glass. Then.
What?
Because it's going through glass.
The window could be open, and the same thing will happen.
The same thing would happen if the window was open.
Yes.
The window wouldn't bend the rays.
I mean, the window would bend the rays, but the same thing will happen if the window was open.
I don't know, bro. I just know that observably, the sun has crepuscular rays like a pyramid. So if the sun was as far away and as big, they'd all be coming in one direction. We both know this already.
Yep.
So
you can look at, so let's do this. We can look at crepuscular rays and we can make a hypothesis and say, I hypothesize that the sun is local. That means that if it were local like that and we saw rays coming in like this, that means someone standing here and someone standing here, their shadows would be going opposite directions.
Not necessarily.
Necessarily, because the sun rays are coming. If the sun rays are coming at an angle, they hit an object here, it's going to cast a shadow this way. And the sun rays coming this way and hit something, it's going to cast a shadow that way. These shadows have to be going opposite directions. Yes.
Not necessarily.
Yes.
I mean, like I said, we don't know what the sun is. No. That's saying if the sun is an actual physical object. We don't know.
So are you saying that sun rays can cast shadows in a different direction from which they are coming?
I don't understand what you're saying.
Well, you said that. So we can look at. So we've got our sun right here. We've got crepuscular rays coming down, right?
Yeah.
That means the ray is coming from the sun in this direction, right? The light from the sun is coming in this direction, right? Mm-hmm. That means when I put something here, it's going to cast a shadow this direction. And then we've got the same sun and we've got the crepuscular rays. Something here, it's going to hit it, cast a shadow this direction.
I mean, it all could just be an optical illusion.
I agree, it is an optical illusion. That's what crepuscular rays are, is an optical illusion. Just like the train tracks going off into the distance, making
they don't prove whether it's spherical or flat.
That's why we don't use crepuscular rays.
For what?
Anything. You're the one that tried to use crepuscular rays as evidence of the Earth being flat.
No, I didn't.
Or sorry, for evidence of the sun being local.
Yeah.
Yeah. So I'm not trying to.
If the sun was local, we could still be on a globe.
You're right, but it's not local verifiably.
Okay. It's all theoretical, bro. We don't know.
It's not theoretical. We have measured it.
Touch. It's not tangible. You can't physically go to it.
Can you touch your brain?
Can you touch my brain?
No. Do I know you have a brain? I mean, you probably do. But does that mean the fact that your brain, does that make it theoretical?
I mean, you've never seen my brain. I've never seen it. I don't know
Correct.
for
Does
sure
that
if I
mean
have
that
it.
your brain is theoretical?
Yeah,
All right.
until proven otherwise.
Okay, great.
So I was just going to inject here and just say if we had any other talking points that we might want to put a bow on, it's up to you guys. Generally, around this time we will go into the Q&A, but if you guys want to keep going, if you had other things you wanted to unpack, I know FlatterDay Saints, you had you jumped in a few times, and I think you kind of wanted to go down a few paths. So if there's something that you didn't get off your chest, you're welcome to it. Also, you could take a break as well if you wanted to step out and grab a refreshment. That's fine. So feel free to jump in, FlatterDay Saints, though, if you wanted to push into a different zone there for a little bit.
I mean, besides the fact that Earth is observably a level plane, I don't really know what other things you want me to disprove about the globe or level about the globe. As far as like most of the things that you say could work on either a globe or a level plane, so they don't really prove the globe one way or the other.
So it's my claim that they don't work on a flat Earth, and you have not been able to show that they do work on a flat Earth.
It would work on either model.
But you haven't been able to show that. You've just said that it does.
Yeah, I don't
That's
have
a
a
truth
flat Earth
claim.
model though. I just have what we observe.
But you said that it does work on a flat Earth.
It would work on either.
Right. You said that it does work on a flat Earth. I
Yeah.
believe that that is incorrect. And I now want you to prove that it does work on a flat Earth.
I can't prove that it works on a flat Earth or a globe. I'm saying it could work on either or.
Right. I'm not saying anything about the globe. I just want you to prove that it can work on a flat Earth. Whether or not it works on the globe is irrelevant to you proving that it works on a flat
Zodiac,
Earth.
like I said, the Zodiac wheel proves that. They're still using that, and that's from the flat Earth model.
But you didn't show me that it is from the flat Earth model.
I don't even know how to pull stuff up on the screen like this. So you can just Google it and see, or anybody in the audience can Google it and see. Don't take my word for anything. Just use your own common sense and your own observations about this, the shape or lack of shape of the Earth.
What specifically would you like me to Google?
Google Google if the Zodiac wheel is based on a heliocentric model.
Give you a second to type that on in, and once again I'll remind our audience to smacketh of the liketh, and let's see, we got just shy of 500 watching right now, so yeah, if we can get like another 150 likes or so, maybe I'll just put a really serious poll in the chat for everybody to have fun with. So over to you, ADHD.
Hey, people over on TikTok, go to YouTube right now and go like this video. It is on Modern Day Debates. Go like it. Okay, so a cursory, very first thing that comes up on Google when I say, is the Zodiac wheel based on the heliocentric model? Says, the Zodiac is an 18-degree wide band of sky encircling the Earth. Often, it is likened to a wheel with 12 spokes. Traditionally, it is a geocentric datum with the Earth sitting at the hub, but it is often shown from a heliocentric perspective. It works either way.
All right, bro. So basically, like I said, that they're still using a flat Earth model.
But it just said that they're not, though. They traditionally
said
did,
they were.
but they're not now.
Traditionally. So when did it change?
I don't know.
It's still based on the wheel, it said.
But based off of the Google search I found, it says that it does work on the heliocentric model,
No,
which
from
your
their
claim
perspective.
was that it doesn't.
From their perspective. But no, I wasn't claiming that it doesn't. I was saying that they're still using a flat Earth model, a geocentric model, I should say.
Okay. Is there anything that does work on a flat Earth that doesn't work on a globe?
Pretty much everything. Everything as we see it, everything that's observable to all of our senses.
But everything that we've talked about today, you've said works on both. Is there anything that only works on flat Earth that does not?
Because everything we were saying couldn't be verified one way or the other.
Star trails in the southern
You're saying they
hemisphere
can
can't
send
be
signals
verified?
to. You're saying they can send ham radio signals to the moon or to the sun, which is a false statement. They can't send those signals. Don't go on indefinitely.
Can you show me that? Can you show me that they lose that? Because everything that I have ever
read the
seen.
propagation of electromagnetic fields over flat Earth.
Okay, so that doesn't say that they lose their ability to travel, though.
Have you read it?
Okay, so give me what the name of it is again.
Propagation of electromagnetic fields over a flat Earth. Army Research Laboratories.
That's quite a bit to remember there.
Okay,
Hopefully
so
I can pull it up. You can share your screen as well if you'd like to show the audience what you're finding there. But
okay, let's
it's up to you.
I can't share my screen at all.
No, you're good. I've got it up.
Okay.
No worries.
Let's close out of those.
As long as this is what you're looking for, is this good?
Is
FlatterDay
is this right?
Mm-hmm.
Okay, so and let me make sure that my peeps over on TikTok can also see this.
We can see your peeps on TikTok. TikTok. Hello, peeps on TikTok.
Okay.
Ryan can't
and they're
speak
sharing
tonight.
different screens.
I just see his phone over and over and over.
That's like the Wait a second.
Yeah, we've got your phone on top of everything, so we're looking at your TikTok.
Peeps over on TikTok, you're gonna have to sit tight for a second. Okay.
Sorry, peeps on TikTok.
Okay, so propagation of electromagnetic fields over a flat Earth. What part of it do we need to read? Is there anything specific? I mean, this is 33 pages.
33 pages. That's so fun.
Okay, so vertical dipoles over an Earth, horizontal dipole over Earth, comparisons. Fresnel reflection coefficient. Is there anything? Comparison of principal fields from an ideal dipole. Is there anything? Where does it say that electromagnetic waves don't travel forever?
Yeah, that's propagation means how far they travel. How are you getting them to travel?
So propagation doesn't mean just how far they travel. It means how they travel. Mm-hmm. So is there anywhere on here that backs up this claim?
About signals. Signals only have a certain attenuation. They don't go on forever, bro. If that were the case, then we would never lose signals on our cell phone.
So they don't go on. They go on as long as nothing stops it. Things can get in the way. Yes, I agree. Things can absolutely get in the way. Things like our walls, things like a mountain or really, really dense atmosphere. A very major problem that we have with communications is that we have to go long distances across. And that there's a lot, like if we want to send a radio wave 30 miles, that's 30 miles of atmosphere to get through. However, if we want to send a radio wave to the sun, there's only like 7 miles of atmosphere for it to go through. As long as that radio wave, in fact, I should look up.
So you're saying you think the sun's only 7 miles up?
No, I'm saying that the atmosphere is only 7 miles thick, and 7 miles is probably the incorrect number. Okay, so
I don't think there's an agreed upon number for that. I think it's all theoretical.
Sorry, 60 miles. Okay, so So 60 miles. As long as we can get a radio wave to travel 60 miles, it can get out of the atmosphere and into space, and then travel with next to nothing blocking it to the sun and then back.
So you're invoking an environment that we can't independently verify.
What do you mean we can't independently verify?
Neither you or I can independently verify that. We're just going by what somebody said.
So I'm going off of science. Whoops.
That's such a general term.
You're using the same argument of radio propagation. I say that there's space, and you say, well, that's just what someone said. You say radio waves and propagation over a flat Earth, and they slow down. That's what someone said.
I didn't say they slow down. I say they die out.
That would be slowing
down. Imagine a radio wave.
They keep slowing until they stop.
Yeah, a spiral. It gets wider and wider and weaker and weaker.
Right. So the radio waves go out, and it's actually a sphere that it goes out. It's a sphere that they go out. Yes. So they go out in a wave. But that wave, as long as nothing gets in front of it, can travel forever.
That's not true.
Okay. Your reference, I didn't see anything that said that was incorrect. It shows how radio waves propagate over a flat plane, like how they move through it. Have you read this article or this page?
I haven't read the whole book, no. The book is very contrived, and it keeps going. It basically, to sum it up, it says that basically they're going over a flat Earth, but for all intents and purposes, we can't say that it's a flat Earth, and it's all double speak, Hegelian dialect, because no official document can ever, as far as like to the public, is going to say that the Earth is flat. They're going to do their measurements and stuff over it. When pilots learn to fly a plane, they take their training courses, and they're supposed to assume that it's a flat, non-moving stationary plane.
That is incorrect.
Oh, so they're not supposed to assume that?
I know several pilots that have said the opposite.
So during their training, they assume that it's a spherical moving surface?
Correct.
So then why would their training manual say to assume
it doesn't?
It does.
It doesn't.
NASA flight training manual does it?
No, it doesn't. That's not a NASA. It is not a NASA flight training manual that you are referencing.
What am I referencing then?
You're referencing the way that they build planes. They say it's where it's assumed a flat, stationary, non-rotating globe, right? That's what they're saying.
They don't say globe. They say a flat or a stationary, non-rotating plane.
Earth.
Yeah.
Yes, and then what they say right after it is you also assume a rigid body plane that doesn't change mass. Never is there a rigid body plane that doesn't change mass. So that's an assumption, and they say this in the paragraph that you're referencing. They say this is an assumption for simplicity.
Why would you assume that, though?
For simplicity. And the reason that they say that is for people that want more accurate numbers, that need more accurate numbers, they have to take these things into effect. Now, why would they say assume a flat Earth because it's actually flat, and then also say assume a rigid body when no rigid body is actually rigid? They're assuming there are two things. One you claim is true, one is not true.
Yeah, why would they have you? Why would they assume the shape? Why would they assume that it's a flat, non-rotating plane?
Why would they assume that it's a rigid body of unchanging mass?
That has nothing to do with the shape of the Earth.
It's the same sentence. In the same sentence, they say, assume flat, non-rotating Earth and a rigid body of unchanging mass. That's what they say.
So you're saying that sentence each part of the sentence contradicts it?
No, I'm saying that each part of that sentence is a simplification to make the math easier.
To make the math correct.
Easier.
Which would
It's
be
not correct.
incorrect
That's
still?
why they have to say it. If they didn't state it, someone that would try and do a more accurate prediction based off of this math would be wrong because they don't take these things into account. That's what it says.
They're not taking the curvature into account.
They do. That same document also says that this is for suborbital flights under a certain speed.
So why
pretty sure.
you can have something that's orbital going around, like the hands on the clock?
Orbital as in going into orbit around the Earth.
Okay, well, if you're going to get into that, what is it that makes the plane dip according to the curvature of the Earth? Is it built into the plane's technology?
It's built into gravity.
It's built into gravity.
Mm-hmm.
So, does the pilot consciously dip the nose of the plane
Nope.
down, or is it
Gravity
built into
pulls
the
it down.
controls? But also, the pilot can pull the plane up, though.
Yes, the pilot
controls
can.
the plane.
The pilot can pull the plane up, and the pilot can make the plane go down. Gravity also makes the plane go down. That's why if you turn off the engines, it will fall.
So, what if you pointed the plane straight up into the sky?
Then you would
gravity
stall.
keep you down?
Yes, gravity would keep you down. So if you pointed straight up in a plane, you would stall because it requires a horizontal motion in order to fly. This is why they're called planes. They plane over
the plane,
in the air. If they go straight up, they will stall. That's why rockets have really, really big engines. So if they go straight up, they stall, and gravity pulls them back down.
Rockets actually make like a rainbow shape. And they come
Not
back
all
down.
of them.
No, some of them stop after they hit something, or
Some of them go straight up into outer space. So the ones that make the ones that make the little arch like this, those are the ones that are going into orbit. Now, on a globe, in order to go into orbit, you have to start going around the globe, right? And so if it takes off and keeps going this way, it can't go into orbit. It's not going to go up and then make a 90-degree turn and go into orbit. It's just going to start going into orbit. That's what you're seeing.
So if the rocket were going according to the spherical shape of your so-called Earth, the orbit or the arc that the rocket's making would have to be bigger than the Earth if it's going on the outside of the Earth. Then we wouldn't see the arc.
We wouldn't
even see the arc.
Yeah, we would.
The arc we're seeing is way smaller
we would see it
than
arc up, and then it would go down into it would. We would see the arc go up, and as it went around the curve of the Earth, it would intersect with the horizon.
So, but you're not seeing any curvature that it's arcing over.
But this is what's to be expected, though. If the rocket were to take off and go around the Earth, that's what's expected.
It's not what we see, though.
You just said it's what we see. You brought it up as when rockets take off, they make the little rainbow. That's what you said.
So it goes back down.
It goes around the Earth.
So then that means the curvature of the Earth or the radius of the Earth is a lot smaller then.
No, it's not.
Than what they claim to be. No. Otherwise, the plane would make a larger arc than the curve of the Earth.
It's making a really. How big is that arc?
It's not as big as the supposed curvature of the Earth.
How do you know that?
Because you don't see any curvature where it's going over.
But you don't know that it's bigger than the curvature of the Earth. You didn't measure it.
It would necessitate that. It would necessitate that.
You don't know that.
If it's going on the outside of a ball, it would have to make a bigger arc than the ball.
It would have to be. Your claim is that it's not. You do not know that.
My claim is that the Earth is not curving underneath it.
Okay, but you're using this as a proof. How do you know that arc?
No, I'm just using it to falsify your
claim. How do you know that arc?
I'm not trying to
how do you know that that arc is?
Your claim.
How do you know that arc is less than the claimed curve of the Earth?
Because you can see where it dips down again.
Okay, but how do you know that arc is less than the supposed curve of the Earth?
Because you don't see any curvature for that distance.
How do you know that the arc is not the supposed curve of the Earth?
Because it's a lot smaller than the supposed curvature of the Earth.
How do you know that?
Have to be bigger.
You're just saying, I know that because it is.
Because it's observed.
How do you know?
Because where it arcs, you see no curve of the Earth.
Because it's in the sky.
Why is that
so how do you know that the arc that it's making is less than the curve of the Earth?
Because it's observable.
How do you know that? that? You're the one that's getting
Because
on
I
me for
see it.
measurements. You don't
I
have
see
a
it.
single measurement, yet you're making a claim.
No, I'm not.
You
I'm not
have
making
no
a claim.
measurement.
I'm
You don't
only
know.
falsifying your claim. I'm not making.
You're
the
not
claim.
falsifying anything because you haven't measured a thing. You're saying it's less than the supposed curve of the Earth. You don't know that. How do you know that? You didn't measure
Because
it.
it's observable.
You didn't measure it.
There's no curve where it's arcing.
It's in the sky.
Mhm.
How do you know that?
There's
How
no
do you know
curve
that?
it's arcing over. It's observable.
How do you know that the arch that it is making is
Because I
less
can
than
see
the...
that it's arching over a flat plane.
How do you know that the arch that it's making is a smaller arch than the supposed curve of the Earth?
Because it's observable.
But you didn't measure it.
It's observable though.
You didn't measure it.
Okay.
Measure what? How straight it is?
The arc, the size of that arc.
It's
You're
observable.
making a claim that that size of the arc is less than the curve of the Earth, but you don't know
Yeah.
that.
I'm just
observable
going to
that
jump
it is.
in. So sorry, guys. It does seem like once again we're kind of going back and forth with the same type of idea there. So it might be like I said earlier. We do have some questions in our Q&A,
Perfect.
and I do expect a few more to come in as we start moving through Q&A. So maybe that's what we'll do. We're going to use our audience questions to help prompt our conversation. So let us know what you think and what you'd like to hear from either side of our debaters. And once again, hit that like button if you enjoyed these debates, and even if not, just boost us up in the algorithm, because it's always great once again to get these open discussions out and about. There you go. I'll pull that
Showing
extra
your accent there.
Yeah, I'll pull that extra Canadian out for you. Aeon Flutter for $2 Canadian. How about that? Is communism for flat Earth or against? This could be a can of worms, so we'll just see how this goes. So, did you want to respond to Aeon Flutter there, FlatterDay Saints? Is communism for flat Earth or against?
I don't know. Communism is just something that's conceptual. I mean, everything is for flat Earth because we live on a flat Earth. It's observable. So all these
Circular
things that you're
logic.
saying are all on a flat Earth.
All right. It's a bit of a strange question. So sorry, Aeon Flutter. We might not get too much more from that one. But we do have LJ, who is often here asking questions even if it's not a flat Earth debate, any debate, LJ is going to be here saying even his dog knows, and I'm waiting for it, LJ. Why doesn't Earth spin under a hovering helicopter?
Because the spin of the atmosphere matches the spin of the Earth. And so when the Earth spins, so does the atmosphere. The helicopter is inside of the atmosphere.
So then, why would they have to take Coriolis into account for sniper rifles?
Because Coriolis is when things are moving through the atmosphere, not hovering stationary inside of the atmosphere.
So it kind of works both ways then.
No, because the question was about a hovering helicopter stationary. So you were talking about when things move when things move through the atmosphere in relation to the spinning Earth, then you have to take Coriolis into effect. When things are just hovering stationary, they're just glued to the Earth, so they don't care about Coriolis.
So the environment isn't cohesive with the Earth and pulling it?
It is cohesive when something, so the Earth is spinning and then we shoot a bullet and it's spinning, we have to take that into account. That's what Coriolis takes into account.
So it would be cohesive whether it was moving or not.
What would be cohesive?
A different law apply to that?
Say that again.
How can you apply a different law to that?
Because
the Earth is moving underneath us, it's going to be moving whether you're shooting a bullet or whether you're in a helicopter.
Well, because the helicopter, so the atmosphere is moving with the Earth, right? The helicopter is in the atmosphere also moving with the Earth. The bullet is now moving in relation to the atmosphere and Earth. That means that the bullet is moving independently. I mean, it still has angular momentum, but the bullet is now moving inside of this rotation. So It's like have you seen the merry-go-round where someone's sitting on it and then they throw a ball and the ball kind of arcs off to the left because it's spinning? Have you seen that that example?
I'm not sure. I just know that one of your theories debunks the other one.
It doesn't, because they're two different things. So imagine you know merry-go-rounds, those things on the parks that you spin and you hold on to, right? That's a merry-go-round.
Yeah, that if it went fast enough and you didn't hold on, you'd fly off.
Yeah, exactly. So if you were sitting on that, if you were sitting on that, and you threw the ball would appear to arc away from you. But if you put a camera up top and filmed the merry-go-round, the ball would actually move in a linear path. You are moving in relation to the ball. That is Coriolis. If you were just holding
in a linear path, so you're
right, it's linear based off of it's linear based off of different reference frames,
like our observations.
Right, and so
in
the example of the merry-go-round, when I'm holding the ball, my arms are the atmosphere, or I am the atmosphere, and the merry-go-round is the earth. Once I shoot the bullet or throw the ball. Now, because the ball is moving, then Coriolis takes effect. So Coriolis only matters for things that are moving through the atmosphere, not things that are stationary on it.
Yeah,
because when you're standing here,
for everything or matters for nothing.
No, it doesn't. It matters for specific things.
So bullets, but not airplanes.
Airplanes have Coriolis, but the Coriolis is too small for an airplane to care.
So a bullet's traveling roughly 825 miles per hour. A plane is going about 500 and something miles per hour.
Right.
So at what point between the 500 and something miles per hour that a plane flies and the 825 that a bullet goes, at what point does Coriolis come into effect?
It comes into effect both times. However, if you are a foot off with a bullet, is that going to matter more than if you're a foot off on an airplane?
I mean, what matters isn't really the question, because what matters is just something of opinion.
Right. So the airplane does experience Coriolis. However, there is a pilot inside of the airplane constantly just flying. He's not going to know that he's correcting for Coriolis or even care. He's just flying to a destination. It's like you don't know that you're slightly drifting in your car. You're just driving. So there is Coriolis on an airplane. You're just flying, and it doesn't really matter because you're constantly correcting for wind patterns, because wind pattern will cause more drift to an airplane than Coriolis. And since you're just constantly correcting, it is auto-corrected as you're correcting for other variables. And if you're off by 5 feet in an airplane, it doesn't matter. But if you're off by a foot in a bullet, it does. That's why we care about Coriolis and bullets and less on airplanes.
You're saying, though, that the wind could be moving in a different direction than the Coriolis in an airplane.
Right? The wind has nothing to do with Coriolis.
No. Exactly. Okay, so then you said everything's cohesive, though, moving.
What do you mean So the
wind's going in different directions. How can it be cohesive?
So wind is moving in relation to the atmosphere. That's just high and low pressures. But like the atmosphere as a whole is all moving together. It's like if you're in a car and you or on a train, you can move up and down the train, but that doesn't mean
if you're in a car or a train that's convertible. Because you're talking about something with a closed environment.
No, yeah. So I'm talking about.
I mean, if you are referring to that as the Earth, then you are correct in saying so. I do believe that it's an enclosed environment.
But that's not what I'm talking about here. If everything is moving together, I can move up and down on that train all day, yet the train is still moving forward. So wind patterns on Earth can still happen. The entire thing is moving all together with all of those moving around inside of it. And yes, wind patterns do experience Coriolis. That's why in the northern hemisphere, giant tornadoes in the ocean, hurricanes will spin one direction, and then on the southern hemisphere, hurricanes will spin the opposite direction. It's because they're experiencing Coriolis because they are moving independently of the rest of the atmosphere.
So then it's not cohesive.
The atmosphere as a whole...
You said they're moving independently, which means they're not cohesive.
The atmosphere as a whole is moving together. things inside of the atmosphere can also move, but things that move inside of the atmosphere experience Coriolis.
I don't know if you realize what you're doing is double speak.
No, it's not.
All right. We'll let the audience decide.
Okay.
All right, let's
Fine
carry
by
on.
me.
Yeah, we got a couple more questions, and yeah, if you're hanging out in the live chat right now and you have thoughts about everything you're hearing tonight, let us know. If you put in a super chat, then it will be read with priority. We will definitely read it. And I will once again let our speakers know if they wanted to take a moment to either grab a drink, or if you need to take a bathroom break, that's totally fine. I can pick up the broom for a second if you guys need. No, nobody's objecting. All right. Everybody's got their catheter, I guess. Anyways, no, sorry, I'm terrible. All right, so LJ says, if you dig straight down, will you come out upside down?
Yeah, so this is actually a really fun physics problem. So if you don't correct because as you dig down, gravity is going to change. You'll be digging down until you hit the center, assuming that you can dig through the center and it's not like gonna burn you up and turn you into lava. Assuming you can dig down, so it'll seem like you're digging down, and then you're gonna get to a point that it seems like you're digging up. And it's an interesting physics problem. So yes, eventually you will have to start digging up with gravity pulling you back towards the center, because gravity will always be pulling you towards the center. It's a very interesting problem, and I've encountered this problem ever since like the 9th grade when I first took physics. If you like jump through a hole that's through the center of the earth, what's going to happen? And you can calculate that based off of like expected gravitational pulls. So yes, at some point you will appear to be digging up, but it's a weird question and something that we're never going to experience. But theoretically, not the right form of theoretical. I guess, yeah, theoretically, yeah. In the theory of the flat Earth or the globe Earth, yes, you will start digging up.
Cool story.
It is a cool story, and I hope one day that we actually get to jump through the center of the Earth, because what's going to happen is you're going to jump in and you're going to fall until you hit the exact center. And then at that point, you're going to start rising because you're still falling, but gravity has now switched directions. And as you fall, gravity will get less and less as you get towards the center. And then at this very center, you're weightless, but you still have inertia, and that pushes you out the other side. And your inertia is enough that it will get you right until you hit the top of the hole, and then you're going to start falling back down. So you better have someone that can grab you, because you're just going to barely come out of the hole, and then you're going to fall back down. And you're going to keep doing that forever until friction of the air slows you down enough that you will stop in the center of the Earth.
And that's your theory. Good theory.
Yeah, it's all based off of the theory of the globe.
So you said the further down you go, the gravity lessens the further down into the Earth you go. It gets weaker and weaker.
Yeah, because it's based off of mass.
So
how much
the higher
mass...
up you go, does gravity get stronger and stronger the higher up you go until it gets to a weaker point again?
Wait, does gravity get stronger the closer you get to the center, or?
And I don't believe in gravity, but I'm just asking.
I'm trying to think of how gravity works, because gravity, as you go further down, I have to remember the explanation. As you go further down, there's more mass on the outside of you, and so gravity would be pulling more and more to the side, but it's equal on both sides, so you won't actually move either direction. Say that again.
If gravity's attracting everything to the center, then how is it pulling to the side? Like how do things even
gravity pulls things to a central location.
But you think gravity gets to pick and choose?
What?
Does gravity get to pick and choose?
No, it's not picking and choosing. It's different based off of where you're at. In fact, gravity is...
You could take a 5-pound magnet and hold up a 100-pound piece of iron indefinitely, and then gravity just chooses not to pull it down.
What happens if that magnet demagnetizes?
What if it doesn't?
It still is pulling that down. You still have to have a force holding the magnet.
Let's say you took a blowtorch to the magnet and made it glow. You demagnetize it, right? The
blowtorch and the weight would fall.
Your theoretical gravity.
the weight would fall. So the thing is, there is something called summations of forces. Okay, so think of it as a tug of war. Okay, I'm on one end, and my 7-year-old nephew is on the other end. I'm pulling. I'm gonna pull him. I'm the magnet, and the center of the rope is that weight. Okay, I can pull it more, but if I let go, he's gonna pull the magnet the other direction. The sum of the forces were in my favor because I'm a stronger force. Magnetism is a much stronger force than gravity, and
And
it
why
will
is it
pull the weight
magnetism
up
invoked? How come gravity is invoked over magnetism if magnetism is a much stronger force?
because it's not magnetism.
Getting pulled to the ground.
What?
So you're saying gravity is not magnetism.
Right.
So if gravity were in effect everywhere, why would when we jump into the water, why when we hit a low point, why do we rise back up?
Summations of forces again. There is a force due to buoyancy, and so the
Yeah,
buoyant
buoyancy.
the buoyancy force is pushing up while gravity is pushing down.
So
So
gravity
that again
isn't
is the
that strong.
summation of forces.
Okay. So why is gravity invoked if all these other forces are stronger?
Because those forces don't explain why if I drop my pencil it falls down.
That would be density.
No,
It's denser than
density.
air around it.
So density doesn't impart a force on anything.
It's because of density the objects fall if they're heavier than the air that's around.
So things of different densities should fall at different rates, if that's the reason.
You can't prove that they fall at the same rate or different rates.
I can, yes.
Okay.
You can show me an experiment where they drop something a couple inches or a foot.
I can show you an experiment where they drop something from 20 feet in the air in a vacuum, and the feather and the bowling ball falls at the same rate. Sorry, we can go to the next question.
No, I was going to say keep her going.
Say that again.
Go ahead.
That would be great if we lived in a vacuum.
Right.
But
so because air is a
vacuum.
thing, there is again that summation of forces. As things fall, the air pushes back at it. Air has a resistance. It's called air resistance. And so as things fall, they have a different air resistance because a feather doesn't
things do
fall.
at different speeds.
Right, they fall at different rates because of air resistance. So if we can remove all of the air and only have them be affected by whatever magical force is pulling things down, they fall at the same rate. Showing that it's not density that is the determining factor because things fall at the same rate regardless of their density.
In a vacuum.
Right, regardless of their density.
So in a controlled environment that's not realistic to the environment we experience.
But it is still an environment here on Earth and is testing the downward force on Earth.
So just very quick before you respond, FlatterDay, if you could move your mic forward just so you're speaking a little bit more into the mic. It's okay.
Sorry, my bad.
It happens. We can still hear you. It's just if we could hear you a little more clearer, it would be good. But yeah, if you want to respond to that, or we can move on.
Well, as long as you heard what I said, then that's all that matters. Truth goes forward and doesn't come back void. So my conscience is clear. If I were to die today, right now, before my Creator, I solemnly swear and attest to everything I said knowingly is true and observable.
Same.
Alrighty, let's carry on with Kango44, and thank you so much, Kango, for being here. Always good to see you. Just a quick reminder, Flat Earth people have been offered, I'm not sure what Flat Earth people means, but you know, maybe we can clarify, have been offered a free trip to Antarctica to film the 24-hour sun. This would give them a free opportunity to prove their position. So far, they have all said no. Any thoughts over their FlatterDay Saints?
I'd have to get a pass from my probation officer to go to leave the state. So maybe you guys could write a letter for me, and my PO would probably approve it because she's a heliocentric, and then we'll all go off into Antarctica together. Cool story.
All y'all going off to Antarctica.
I super wish if I wasn't going to Australia that same week, I would be fundraising to go down to Antarctica.
Cool.
Alrighty. Meriton, thank you so much for your super chat. Actually, sorry, before that, thank you again, Kango44. LJ coming in with another one. What size does sea/ocean water start to curve?
At all sizes. So if we look at a little tiny drop, if you put a little tiny drop on the table, it will be curved. That's just the cohesive properties of water. It's always just curved, and then so it's always curving at all points. So as it gets bigger and bigger, it just is still curving. Are
Even
you
the
talking about
levels you
like
showed of level red water in those vials, was that curving?
what? Say that again.
The picture you showed of the vials with the red liquid.
Yeah, they curve cohesive to the curve of the Earth. Yes, but over
No,
that,
no,
seeing
they were in the vial though. They were in the vial, and from the
yeah,
top, it didn't look like it was curving. It looked level.
yeah. So it looks level. It's just really really small because if you have a really giant Earth and you are only looking at this little teeny tiny portion of it, it's gonna look flat, but it will still be curved just as much as the rest of the entire Earth.
Okay, maybe that's a good point to move on from. Seems like we've got a. I don't know if we got consensus or if we're just ready to move on, but let's carry into the next super chat. Meriden says, "How do you explain that at about sunset/sunrise, it is possible to observe the sun shining on the underside of clouds, even though some, where it is noon, would tell you the same time that the sun is well above the clouds?" Ooh, that was a mouthful, but I think we got it. Do you understand?
Trails.
Sorry, go ahead.
I just said chemtrails.
So what they're talking about is sometimes when you're standing underneath the clouds, they've got clouds up here. You can see the sun coming to the top of, like, coming from down and shining on the bottom of the clouds. So that would mean that the sun is physically below the clouds. Yet other people, where it's noon, will say that the sun is much higher than the clouds. That's something that comes from us standing on the globe, and the sun's over here as it sets. It is shining up at our clouds, but over here it's daytime.
All right. Next one was a membership chat. Thank you so much to Meriden. So the Piley says, "Great to see you, Ryan. My favorite Canuck." Oh, wow. You really hate Canadians that much? No, I'm just joking around. Well, thank you so much, the Piley, if that's how you say your name. But I appreciate that. So let's carry on. And of course, everybody knows that I am indeed a Canuck. Let's see.
What?
Whoa, crazy. What's that all about? All right, Earthly Skeptic says, "FlatterDay Saint. When I see an airplane fly at 40,000 feet, its nose appears to point upwards until it makes a closest approach to me, and then it points downward. Why?"
I've never seen a plane's nose point downward. Even when they're landing, it's still pointed either level or upward. It would rip apart the plane if it were pointing his nose down.
Any thoughts on the other side?
Perspective. So what they're talking about is as the plane is coming towards you, it will look like it's the nose is up, and then as it's going away from you, it will look like the nose is slightly down. That's the perspective thing as it comes across your perspective.
It's never looked like it's pointing down, even if it's passing.
I see it all the time. That's the perspective.
You said you see the curvature of the Earth too.
As it's coming towards us, the plane looks like it's kind of pointing up, but as it's going away from us, it's kind of pointing down, and that's the perspective.
I've never seen it.
Okay, I'll take a picture of it next time I see it. I'll send it to you.
What kind of camera do you got?
An iPhone.
All right, last super chat for now coming in. So if you have any questions, you better get them in now. If not, we are going to end on this super chat and then go into our closing statements. And there's not a whole lot to chew on with the super chat. So once again, this is the last chance I'm going to shout out for the likes on the stream. Thank you everybody for letting us know what upcoming topics you'd like to see on Modern Day Debate. If you want to comment in the like section, just very simply like one statement of what type of debate you'd like to see on Modern Day Debate. I do check out those comments from time to time, and I'll see what you guys are feeling in the post show, as well as the the poll that I had up there, which I will do a new poll to close the show. So, Mustafa Jav says, love this channel to death, but if I had a nickel for every flat versus globe debate, I could pay off James Coon's student loans. Mix it up. So, adding a little bit of context to my prior statement. But what's going on, ADHD?
Well, I mean, I am open to moon landing denial and dinosaurs. Not evolution, because I'm not knowledgeable enough, but like the existence of dinosaurs. So if anyone wants to debate those two things, let me know.
Yeah, I guess it would be a good time to ask as well. Are there any other topics that you would also like to debate on the channel going forward, FlatterDay Saints?
Yeah, direct energy weapons, chemtrails, and radium.
And what?
Radium?
I don't think I know what you mean by that.
Radium, like what they used to power things with before they decided they wanted to charge us for electricity and they got rid of the radium. It was no longer made after 1943 because they said they needed it for the Manhattan Project.
Well, I will let you know. I just
they used to have fireplaces with no chimneys, basically.
I'll have to look into that. I have not heard that one.
Well, I will let you know. Unfortunately, I just closed the poll in our live chat. So currently, the appetite of this debate, and of course, this is a more space-related debate, so we might have a bias in the chat for this discussion. But I had, what kinds of debates would you like to see on Modern Day Debate? So I closed the chat. 40% said space debates. 24% said religious debates. 20% said social political debates, and then 14% said technology debates, AI, energy, etc. So it does look like space debates wins that poll there. Earlier I had the Earth is. Globe had 65%, flat at 23%, and then Halo, Donut World, 10%. Anybody is welcome to add me on Steam and play Halo with me. That is fine. I always need multiplayer co-op people to help do
It's
speed.
funny that the globe is 65%, since 65 is FE.
Yeah, well, here, that I was going to say, honestly, that it does seem like, especially since we had to change things up last minute, that this was a very diverse audience. So we do appreciate.
65 is FE. You understand that, right?
No, I have no idea what that means.
It's alphanumeric. FE before G.
So 65, like in hex, like alphanumeric.
Like 6 is F and 5 is E.
I was just gonna make commentary on the undecided people, but Timcast did put in 99 cents. I'm not sure if you had a question, Timcast. If you want to let me know in the live chat if you wanted to attach a question to that, Timcast. If not, what I'm gonna do here is I'm going to give the floor over to ADHD Projects. Thank you so much for being here. I'm going to give you a minute on the floor, unless, like I say, our super chatter wants to clarify in our chat if they have a question. But if not, ADHD, you have a minute on the floor to let everybody know where you're at, and of course, your closing thoughts on our discussion tonight.
Absolutely. So, given tonight, I don't really think I'm changing my mind. I haven't been shown any evidence for a flat Earth other than, it also works on flat Earth. If anyone is willing to send me evidence of a flat Earth, I'm open to seeing it. I'm going to go read this document and see what it actually says over flat Earth propagation. Other than that, star trails, they're impossible on a flat Earth no matter how you cut it, and only possible on a globe Earth. Sunsets don't work on a flat Earth, and neither do the directions that the sun actually sets. And that's it for me.
A1. Well, thank you so much for the closing statement. And Timcast has clarified with another super chat, so thank you so much for putting in another super chat and helping out the channel. It helps us out a lot. And as well, I will let people know that we do have a Patreon and as well a membership at YouTube Live. So check that out, and you can get access to all kinds of funny emojis. They're amazing, as you'll see locked up there if you check our YouTube Live emoji chat. So Timcast says 3-stop right angle flight plan ends flat Earth. Thoughts on that?
Is this my 1 minute ending?
Well, we got a last question, so
Oh, okay, okay.
yeah, I was gonna say. So sorry. So Tim
Say
Cast.
the question again. Or is that a rhetorical statement or question?
So
It sounded
he's
rhetorical.
yeah, he's making a statement. So if you wanted to respond to this statement, Tim Cast is saying 3-stop right angle flight plan ends flat Earth.
I don't even really know what that is. So
So
I
I think I know when. So because the Earth is curved, and this happens on any sphere, like this is just how geometry works. If you are standing here and you go straight and you turn 90 degrees and go straight, and then you turn 90 degrees again and go straight, you'll end up back where you started. And so that's a three that's a triangle with three 90-degree angles. It can only work on a flat Earth, or sorry, it can only work on a globe Earth because it's curved. Um,
Freudian slip, bro.
yeah, yeah. So it can only work on a curved surface, and so they're saying a 390-degree angle flight path will proves that the Earth is a globe. Sorry, and then you can have your closing.
Oh, I was going to say, what I'll do is I'll let you respond, of course, FlatterDay Saints, with that in mind, and then we'll give you your 1 minute closing.
Okay, yeah. So just that's just theoretical. They're called airplanes because they go over a plane. They assume that it's a non-rotating flat surface that they're flying over. Yada yada. You guys have seen the book. You've read the movie. You got the T-shirts. You know what I mean? You got the Happy Meal. I don't know what else I can say. I'm not trying to convince ADHD of anything because like you can lead a blower to flat water, but you can't make him think. So I just would encourage anybody listening to just to forget everything you've ever been taught and just use your senses because your senses are there for a reason. They're to keep you out of trouble. They're to experience pain, pleasure, and joy, and all the things you experience. Imagine if you were taking a driver's test and you were on top of a very curvy mountain and they told you to just assume the road is straight and not curvy and level, you'd go flying right off the cliff. And so, therefore, they don't do that. How much more would they not do that for an airplane or vice versa?
All right. Well,
And if I was in space, I'd say, Mike, float.
All right. And did you want to call that as your 1 minute closing or as your response to the question?
I just wanted to say one thing. ADHD. I'm from the projects too, so I know what it's like. You know, much love. You know what I mean? I feel you on that. I grew up pretty rough.
All righty. So we're
For
gonna... sorry, go ahead.
Oh, so the project's in my name is because like I do random projects, so it's not
You're
not
not
like
from the projects?
no, it's just
Oh,
it's because
okay.
I do random projects. So
Oh,
I wanted to clarify so you weren't like falsely
I'm from the projects, bro.
okay. Nice.
Yeah, flat
was
out of
sure.
Black Swan, Santa Barbara.
Hey, next time we can talk about the Black Swan.
All right. Well,
I'm
let's
from
close
I'm
it
from
up.
the Black Swan, bro. It's from here, from my city.
Nice.
All right, I'm going to close it up there, fellas. So thank you so much, FlatterDay Saints, for your closing statement and also coming out to the platform. We really appreciate it, along with you ADHD Projects for coming out. So once again, hit the like button, whether you're hanging out with this space or other spaces as well. That's always fun and cool. So, once again, let us know in the live chat how you're feeling about our discussion. Let's close it out. And I will let everybody know right quick, just because I see a couple of people are interested. If you do want to debate on Modern Day Debate, if you're on Discord, you can get a hold of me pretty easily through the Modern Day Debate Discord. It is tagged in our description there. It is Ryan Light and Shade on Discord. And if you want to be on the show, as I see a couple people are asking, hit me up through there, and we will. We'll see what you're all about, and then maybe get you on. So, awesome. Well, thank you again to our speakers. Thank you everybody in our
Can I
live
say
chat.
one thing real quick? Can I say one thing?
Sure thing.
Check out my channel. Check out my channel on YouTube, FlatterDay Saints.
Yes, we're gonna get that link updated for you in just a moment. So I'm gonna close it out, and then if you can email me that right quick, and then I'll update our link. Thank you again, FlatterDay Saints, for coming out last minute. So. Once again, everybody, smash the like. You want to. It's there saying do it. Hit it 3 times. That works too. You know, it does special things if you hit it 3 times, and it's still light. All right. All right, I'm going to close out. Cheers, everyone.